This is a Soraa GU10 bulb, 220 volts, 50-60 hertz. We look inside there, we can see the lens, you can see the LED in the back. Of course, that most likely is a compound LED, right? Therefore, basically extrusions that go straight through this aluminum and comes out on the other side here, where they basically pin that lens in by melting the plastic. I've already broken that. The design is very interesting in terms of the aluminum molding. Obviously this is a metal mold to get this kind of precision, but I am not sure if this is separate from this piece or if it's all together. It almost looks separate, how they've done this really close. Again, really an intricate piece of work there, really good quality in terms of that. Again, this shine on it, I suspect it's a paint on finish, not the aluminum, because to get that kind of finish would be difficult. The information is here. I'll have to take a snapshot and put on all the information, probably just type it here on the bottom. But essentially, Soraa is the brand, GU10, 220 to 240 volts, 50-60 hertz, 36-degree angle bulb. I think it's 7.5 watts. And then they say suitable for, sorry, that went off, suitable for damp locations. What I haven't quite figured out, and I'll take a close-up shot of this, these two pins look like they're almost touching the aluminum body, but for some reason it doesn't show it. So clearly that's actually working. Again, let me cut it open, knock it off, see what kind of circuitry they've put into this. These bulbs are relatively expensive. They're over 20 pounds online. This is the lens from inside. It's quite complicated in terms of actually forming. As said before, there are the 4 pins, and those were melted to keep this in place at the back as tabs. Then we have essentially some grating. I don't know the purpose of that per se, maybe to get some diffusion. And then this looks pretty much like a Fresnel lens, so you pretty much end up optically with a larger lens using a lot less material. And then just some tabs to hold it down. Inside of this, we can see 2 wires coming up. We can see the positive and negative written down. So let me open it. There are 2 screws. Let's see what we can get inside further down. So it is indeed 2 independent pieces. It really did seem really, fantastic for it to be one. So those screws come in there. This is the board. That's your positive and negative, as we've seen before. Positive, negative written on that. And pretty much our board looks like it has nothing else on it. I'll take a look into that a little bit closer. Beyond that, what we have here, keep knocking this over, is an isolator insulator in between, and everything inside here is potted. The more interesting one would be this. I really like this shape. It is very futuristic, quite nice looking shape. Good for diffusing heat too, of course. The button is still a problem, but I've at least answered one interesting question I had. This back piece that I thought was aluminum isn't. It's plastic that has been spray painted. So yep, those contacts are not going to short off. So that looks like the oscillating chip there. I can't get a really good number on it. 35 volts, 470 microfarad, which does really compare a little differently from what the actual chip plate here, this plate here says. It is a switch mode power supply, as we can see, the little mini transformer in the back there. These are the 2 inputs which came from the, let me find it, right, this. They basically went straight in, clamped on. These are most likely brass plated, and they're just tabs that have been crimped in there. This is also an interesting piece. I'll put a few photos of this. When it comes down, it says Soraa. It also gives you 94 to 0 volts. There's a number here, Soraa reference number, TC, not sure what that is, and then revision 4 in the opposite direction. So yeah, some little information on that. As can be expected, this is an aluminum substrate, and as with any good manufacturer, they've put heatsink in the back there. That took a little bit of prying to come out, so the heatsink was in a pretty decent enough condition, I'd say. So we get the whole heatsink going on. Interesting that these things come on touchy plastic. This plastic was extremely easy to rip apart, so not very durable, but I guess at least it works. I'm definitely not going to pull out all the button from this. I just want to pull out enough to see what the capacitance was and what the, make sure it's a switch mode power supply, which it is. As I said, interesting though that this says 35 volts here, but this one says 94 to 0. So I'm not sure how 94 volts gets involved in this, if that's a 35 volt capacitor. I mean, I would expect 24, maybe 28 volts, nothing above that with a 35 volt capacitor, maybe 24 volts. So I don't know, but I'm going to just connect this up to 12 volts anyway and see if I get any kind of positive response. Interestingly, there's some dimples on the surface, not sure what that is there for. I've tried it with the 12 volts, no luck, so I don't know. I mean, it does say 0 to 94 volts, so yeah, sure, it should have come on. It did not, so maybe the chip is really dead.